Initially, our project was on news and information. We wanted to try to figure out which news sources were most honest, which ones were fake, and that actually proved to be, as not too surprisingly, quite difficult. We also lost progressive web development. As you know, they no longer exist, Team 2. So we had to kind of pivot and try something new. Initially, we were going to create a plugin that would flag certain articles in various ways that would help the reader to kind of be more cautious about what they're reading. Instead, though, we decided to go ahead and see if a news source was in parity with events happening in the real world. What do we mean by that? Are they correlated strongly or are they correlated weakly? Are the articles they're publishing about a particular topic in step with the actual event rate of that general topic? So here we have the null hypothesis, which is that of course they are, right? They are in step. The news is being super honest. There's no intent to drive you to or away from certain ideas, but we assert the alternative hypothesis, which is that we will get a moderate to weak relationship between the rate at which events are occurring and the rate at which articles are being published. And we're using a cutoff of 0.75 here. So any Pearson's correlation above or equal to 0.75, we would consider to be strong, and anything under that, we would consider to be weak. So these data were sourced from Kaggle, but through the New York Times API. The murder rate data, which is the topic we've chosen as a demo, was taken from the FBI database. So how do we do this? Step one was to get all the data. Got that in the form of 60 CSVs. It's quite a lot. And that was challenging. And how do we get all these CSVs into Python? How do we actually work with these? So I used the glob library, which kind of does what it sounds like, is to grab all files of a certain type that you give it in a folder. And it will do this in order. And so I told it to, of course, go to this location, get all the CSVs and turn them into a glob object. The glob object is an iterable. And so you're able to go through it the same way you would a list, dictionary, or any other iterable. And so all I'm saying is create a database from each file that you see, one after another, and then add them to a list of data frames. And you can do that because data frames are objects in Python. And then concatenated these data frames vertically in order to create a time series. Then I created a filter, used it on that data frame in order to create a sub data frame strictly about this particular topic. And here we retrieved 53,000 rows, and the main data frame had over 8 million rows. So it's a pretty rich data set after being stitched together. Then went ahead and counted how many times the topic of murder was discussed in these New York Times archives for each year from 1960 to 1920, or rather 2021. The reason for that is that the New York Times data goes back to 1920, but the FBI data only goes up to 1960. And so we want those to be in step with each other in order to make an accurate comparison. So I won't bore you too much with this, but this is just a bit of feature engineering. So, we counted the rows, how many rows are in the overall data frame, how many are in our smaller data frame specifically about murder, and we grabbed all the years from the year column of the original data frame as well. We then created this data frame strictly about the topic of murder with these 4 almost native columns. And then we created this derived column here, which is the rate at which articles are published. And we get that number by dividing the number of articles about that topic by all articles that were published in that particular year in order to get the percentage of articles that year that were about that topic. And this is our final data frame. This is, of course, just the head. There are 53,000 rows in this particular data set. Now, why choose the rate at which articles are published and not the raw number? Well, as you can see, from year to year, the number of articles will change kind of, by large amounts, here by tens of thousands. And another important fact is, of course, that the staff at the New York Times also changes over time, which would also impact the number of articles published each year. However, the rate at which articles are published about a particular topic is less likely to be heavily impacted by that rather than the raw number. And I'm actually going to now go on over to Bernard, who will talk about Streamlit and how we created this rather epic application here.
All right, so Streamlit, as mentioned before, it's basically a way for us to deploy our code into a web application. And for the most part, it's actually very simple than writing an HTML. The amount of functions that it was required to create our application was just 8. We used a Streamlit container, Streamlit column, header, title, our table, and our slider. So the idea of like our display, we wanted it to be as interactive as possible for our user. So outside of like the graphs that were created, we wanted to make sure that we had the interaction. So we created a slider, which I'm actually going to go through from the top to the bottom. So the display that you're looking at right now, it's just basically the title, the image. And from there, it just took creating functions right here to match up with what you're seeing. We basically created a function that filtered the data. So the user can go in and basically pre-select the year. And as they select the year, the graph will update. But one thing that we did notice was due to the fact that we decided to use the rate instead of the actual number count, we noticed that we would have to scale the chart in order to accurately reflect that data. And so we went ahead and created a display here for that. But in the future, what we want to do is have the same function, the same interaction. So we're deciding to create like a slider here in order for the user to be able to interact with it the same way. So after we completed that, we decided that for the future of our application, which will be discussed further on, we wanted to explore different subject topics. So we created an interactive multi-selector that will basically do the count of the articles based on the user's interest. So if they're interested in articles about the pandemic, men, women, it'll reflect a count. And as we did the murder rates before, we will try to pull those articles that will, not articles, but pull the source that will create like the rate so that we're able to properly compare what's being published in the news versus what's actually being reported.
Now that we've discussed sort of what the idea behind ColdPress is and the future of ColdPress somewhat, we would like to talk about what we actually did find. So when going through these articles and looking at the murder rate and how congruent it was to reality, we did find a moderate correlation. However, there are a lot of factors that we realize impact the way that these results can be read and should be read. So kind of like what Cornell said in the beginning, the rate of articles posted is what we have to go off of. And that's not exactly congruent with the murder rate and amount of time. The FBI statistic, something that we typically use to measure something like murder rate, is not exactly congruent with news articles. So in our findings, we did find while there is a moderate rate, there were way too many variables for us to actually accurately say if that finding was because murder rates are being reported on as they're happening or because the New York Times and other publications just pick out the stories that they feel will sell. That kind of goes into what we're hoping to get out of this, which is we want to have sources that are more complete, more congruent, and communicate with each other in a better way that will allow us to report on these things in a more accurate manner for a variety of topics. So as you can see, our correlation heat map, it kind of shows you what the murder rate is for the data that we collected through our API research and the rate of article publication. And that is about it.
So ColdPress was built on the idea that news tend to be portrayed in a biased manner. We decided to do this ad because we noticed this issue in our everyday life. Originally, the way that we came up with the idea was that we all had a lot of different things that we wanted to come up with, but this was essentially what we decided upon. And we created data from different APIs and publications, as Cornell shown, that shows how certain news topics are reported or mentioned and how often they're actually happening. Some things that we want to do for the future is that we would like to include having more data on topics that are frequently mentioned, such as immigration or politics, ideas like that, things that tend to be like popular, and in a way that will not be biased to our opinion, but rather let the reader themselves see the actual data and information. So our mission statement is very simple: to keep the user informed about the news that they're taking in and whether that information is as accurate as it's happening. ColdPress will hopefully be able to help understand our news, our world, and each other a little better. But yeah, thank you.